Ooh, it's getting late. Ooh, I'm tired. Busy day. Boys had martial arts. I had to make dinner. I mean get dinner. It's a lot of driving to go get dinner. So, just tired. Anyways, I'm gonna fight through it. We got 3 more problems. This is it. Done for the year. So here we go. I drew pictures for this one first. I don't want to waste time in a video if I have to correct myself or something. I want to make sure it's clear in my head. So we got x equals e to the y. I don't like that. I like this in terms of y so that I can see what it looks like on a normal graph, right? So and this one is not something I can easily visualize. So what I'm going to do is I'm going to solve for y. I have to take the ln of both sides, and when I do that, I'll get the ln of x equals y times the ln of e. We know the ln of e is just 1, so therefore y equals ln of x. Now the ln of x looks like this. It is a and it actually kind of goes, the asymptote is x equals 0. So this guy flows like this, okay, and so this guy has a boundary right there at x equals 1, so we'll stop right there, even though he does flow closer to the y-axis. And then y equals 1 is what it rotates on, because they said here, and it rotates about the line. Now that's cool, because it means there's no space in between the axis of rotation and the function itself. So that is why this guy is a disk. Okay, there's no empty space there. So that's cool. This would be actually a little easier. I find the disks easier instead of trying to figure out what you've got to subtract. So anyways, this piece is going to flow around here. Okay, it's going to spin around that. And so what we want to do is we want to actually, because it's spinning like this, you'll see that I drew an orange line there, and that was a mistake. I thought it was a dy, right? Because I saw that and I thought I had to do a dy, but no. This orientation, okay, is actually because it's spinning around a horizontal line. We have the slice, actually the radius of each individual disk has got to have a radius that is, or the width is a dx. Okay, so this is a dx. Everything will be in terms of dx over here. So this is good because when we do the dx, we already have that ln of x is a dx equation. All right, so what is the outer? Well, let's see. The outer, this guy's spinning. Okay, so he kind of looks like, I don't know, like a jack, like a sharp point here. It's going to come to a sharp point. If this guy spun around, it would look like this. Okay, but we don't have to look at that part. What I'm saying is the outside here. Okay, that is the function, but the entire distance from here to here is actually 1. And if we were to find the integral, this distance right here is what the integral of ln of x would be. We want to get rid of that. Okay, so our outer radius is the 1 minus what's underneath the ln of x. So this whole distance is 1, okay, but we got to get rid of this empty space right here. Okay, and so this is actually attached to the axis of rotation, so he's just going to simply be 1 minus. The outer is the big 1, subtract that ln of x. Now the inner radius is interesting because there is none. There's no inner radius because this is a disk, so there will not be one. There is none. So that's great. So all we got to do now is set up our integral. We've got 1 minus ln of x dx, and we've got pi in front, and we will square that guy. Okay, and the volume equals that, but now we got to figure out where do we go. So we are going from, remember, we got a dx, so we're going from here to here. Okay, so we're going from here to here. Now x right here is 1, okay, because that's where we are told to stop. So 1, but where do we stop? Where does this actually link up? So here's what we got to do. We have to do a little investigation here. We know that y has to be 1 at that point. So if y is 1, what would the x coordinate have to be? Because that's where we got to stop. Plug in 1 into the y. Okay, e to the 1 is actually just e. Okay, so looks like this point is e. So e distance up 1. So this means that we would stop with that evaluation at e. Okay, let the calculator do the rest. Okay, this is a calculator problem. Yep, so you would not do this by hand. Okay, next one. We've got y is the cube root of x, and we are spinning around x equals 8. So we'll put x equals 8, and x equals 8. Okay, so this is going to be a disk. Okay, the reason is if it was x equals 3, we'd have a gap of 5. We'd have to get rid of that radius there. Okay, that pi 5 squared, we'd have to get rid of that. But we're not. We're going to spin around this guy. So what we've got to do is figure out what the cube root of x looks like. But we are going to have to make this in terms of y. Okay, so this guy would look something like that. Okay. All right. Okay, so this means if I plug this point right here. All right, so this is what we're doing here. Okay, because we're rotating around this guy. This is actually a shaded area. Okay, so I'm going to make darken this. This is my dy slice. Okay, because I'm spinning around this way. Now let's think about this. We've got an 8 is this entire distance from here to here, and I got to get rid of that gap right there. Okay, so what I've got to do is I've got to get 8 minus this distance. Now I know that the function is y equals cube root of x. Okay, so I have to put this in terms of y because my slice is a dy. Okay, my integration has to be with respect to y. So this means then that y equals cube root of x. I'm going to go ahead and cube both sides. All right, and there he is. So it looks like this distance right here, okay, is the function y cubed. Okay, so here we would take our 8 and we would minus y cubed. Okay, and there is no inner radius because there's no hole. Okay, we are actually attached. The shaded region is attached to your axis of revolution, being x equals 8. So there is none. And so what we would do is we would say volume equals the 8 minus y cubed dy. Okay, we'd square that guy. Make sure we put the pi in front because we're revolving. In terms of dy, and are we missing? Yeah, we need the upper and lower bounds. So here clearly is 0, 0. So we're going from 0, but remember we're going up. Okay, this is a dy. You might want to think 0 to 8, but no, we got a dy slice. So we're going from 0, and we're going to go right there. So we know that x equals 8, but now we got to figure out what that would be if we plugged an x of 8 into that equation. Our output would be 2. So that's actually 8, 2. Definitely not to proportion here. So this means we would go from 0 to 2. All right, let the calculator do it. All right. Oh, by the way, this is 1 point up here. This is 1.3715 if you want to test yourself there. Okay. And this guy right here is the volume is 576 pi over 7. Where are we at? Oh, okay, 9 minutes. Good. This is good. All right, last one. Whew. Bittersweet. All right. Sorry for the shadow there, but if I turn this on, it just completely washes it out. So I gotta keep this off. All right. So we've got y. Oh, perfect. Okay. So we've got y equals 6, and we're going about the line y equals 6. So there's no gap. Okay. So that's great. I like those. And now we just got to orient ourselves. We know that this is a horizontal line, and we're spinning this way. So this means that we would have a dx slice, okay? Because we have a y equals 6. This guy has a slice, got a vertical line. Okay, anyways, focus. Okay, 2 cube root of x, I'm sorry, 2 square root of x looks something like this. But let me just think if it gets too high. This is y equals 6. So 2 cubed. Let's actually grab. I'm gonna try to do this right. Like, I don't want to sketch. I want to kind of like think about this. So 2. Let's throw in a value x. Okay, if I put in a 4, I'd get 4. If I put in a 9, I would get. Oh, if I put in a 9, I'd get 6. So right there, if this is 9, that's 6. Okay, that's great because that actually touches a line. So kind of got lucky there. So what I did in my head is I'm basically just kind of making a table so I can kind of think about the values that I need, like how I know this guy has to go up like this, but like when is he going to hit that 6 mark? Okay, and so it would look something like this. Okay. Now what are we shading? We're revolving around the y equals 6. So this is actually it right here. If we're revolving around that, that's going to be the, I won't even call it, that's going to be the radius that's spinning. So if we have a dx, okay, and I always label those. If I have a dx, I better put this in terms of x, and that's exactly what I got. But let's just make sure that we get that outer radius correct. The outer radius, okay, this big distance here from here to here is actually 6. But I don't want the whole 6. It's not a rectangle. I got to get rid of this piece right here. And that distance is 2 radical x. So this is 6 minus 2 radical x. That is actually the outer radius. Now, because it's a disk, there is no inner radius because there's no hole that's going to be available there. It's not a bead or something like that. So we go from here. Volume equals pi. Oh man, I almost want to write this slow just to enjoy the moment. No, I'm not. So 6 minus, this is it. Last example. I mean, we'll do like practice tests tomorrow during class Friday, but this is just for you to enjoy over the weekend. Okay, now I'm not trying to slow. I actually lost my train of thought. Okay, we go from where to where. We have dx, so just like here, dy's go down to up. Okay, our dx's, our dx slices go from here to here. So I got lucky there and figured out that it actually intersects there when x is 9. And so therefore I'm going from 0 to 9. Okay, and if you punch that into the calculator, you should get 54 pi, which is roughly 169.646. All right, that's the game. These are going to be tough on the exam. Now, you do recognize this would be in the free response section, and it would be one of the big problems. These big problems actually, you get partial credit for them. So if you can explain your reasoning as you go, and if you make errors along the way, like people get paid money to give students partial credit for these, okay? So if you just take it as far as you can go, even if you don't get the right answer, you can still get a lot of credit for it, okay? So I just want you to kind of keep that in mind that, you know, people are trained to handle partial credit answers, okay? Partial credit grading. All right, talk to you tomorrow.